Hi, kids. This is Mr. Trice. I am with you today to share another math lesson. I hope that you are having a wonderful day. Our math lesson today is our Unit 6, Module 3, Session 3. We are first going to start off with looking at what you guys did yesterday with Mr. Peters. I know he took you guys through some lovely graphs. It was a lot of heavy stuff, but I want to make sure that you are able to see the answers to some of the work that you did. We only had work in our yellow book, so that's what I'm going to be showing you. We didn't have any work in the pink book, the Home Connections book, so you don't need to worry about that. But if you look at page 239 in your yellow book, in front of you right now is the answer key. You had a key that showed all of the different laps that were done by those students, and then you had to put that into a line plot. Now, in this particular line plot, they had all of the data points filled in for you, and you can see that they are in eighths, which makes it really easy. That's something that we want to focus on going forward to make sure that we have a common denominator. And then going up to the key up here, you needed to put each of those data points into the line plot. One of the things that I like to do to make things a little bit easier for myself, is to actually convert some of these numbers right away. I'm going to try to do that for you as I go back out and make this a full screen. So I'm looking at Melissa right now, and it said that she swam 4 3/4 laps. Well, if you look down at our line plot down here, it's in eighths. So what we really want to do is convert that 4 3/4 into 4 6/8. And I apologize. I thought that I had made that line a little bit thinner. But when you do that for each of these, turn these into eighths. If you look at Craig, he has 5 1/2 laps. You could turn that into 5 4/8. We also have Tristan, who has 5 1/2 laps. That would be 5 4/8. Ben has 4 1/4 laps. That would be 4 2/8. And if I continued to go through, then eventually I would have all of those converted into eighths, which makes it really easy then to put it on your line plot. Because if I look at Ben right here and take that 4 2/8, I notice that I can put that right down here. So he would be one of the individual X's right here. So let me move this down so that you can compare your answers. For number 2, it said how many students swam 5 1/8 laps or more. What that means is you want to start counting these X's at 5 1/8 laps. So if I count this X, that's 1, 2, 3, 4, 5, 6, 7. That's how we ended up coming up with that answer for 7. And then the same way for number 3, it said how many students swam fewer than 5 laps. We don't want to start at 5. We want to start at less than 5. So I would start over here at 4 7/8. Count that X, that's 1, 2, 3, 4, 5, 6, 7. That's how they came up with their answer of 7. Then number 4 asks, what is the mode of this data? The mode is just which data point shows up the most. And if we look at our line plot, it's really easy to see. It's 4 2/8. There are 1, 2, 3 X's that show up there. So 4 2/8 is the leader, or if you converted that and reduced it or simplified it on the fraction side, it would equal 4 1/4. And then finally, for number 5, we are looking at the range. The range, again, is taking the highest data point and subtracting the lowest data point. So the highest data point for this is 5 7/8. The lowest data point is 4 1/8. If we take 5 7/8 minus 4 1/8, that's how they came up with the 1 6/8. So that's what range is. All right, we're going to move on to, if this is going too fast for you, at any time you can pause the video so that you can catch up and double check all of your work. But I'm going to move on and go ahead and show the other page that you need to do from yesterday's homework. All right, from here we have a key that shows how far each snail traveled. The difference for this line plot is they didn't give you all the data points for you to write in down here. Notice the reds are the ones that you needed to write in, and this was part of the problem for you to actually fill in those points. Also notice all of the points are filled in as eighths. Since the ones that were already filled in were eighths, we wanted you to fill in the other parts as eighths. Even though not all of the data points up here were listed as eighths, we can convert those. Let me go back and try to fix my pen right now. Do that. Let's see if this works a little bit better. So for A, I would, instead of writing it as 4 1/4, I would like to write it as 4. Nope, it's the same. And 2 eighths. For C, instead of writing that as 3 3/4, I would like to write that as 3 6/8. And then you can keep doing that for each of the distances up here. And then that way you can fill it in down here. So notice that for C, I filled in the 3 6/8 down here as a data point, not the 3 3/4. It's really the same, they're equal, but we're listed as 3 6/8 down here. I'm going to move this down so that you can see the rest of the answers. It says, what is the minimum distance? And that would be, again, referring to range. Well, that would be 3 6/8. What is the maximum distance? That's 4 7/8. What's the difference or the range? You would have to take 4 7/8 minus 3 6/8. If you do that, you get 1 1/8. And then what appears the most? That's the mode. When we look at the plot that appears the most is right here at 4 2/8. And finally, what is the middle value? That's the median. One way you could do it on a line plot is simply do the cross-off method. So I'm going to start on the left. I'm going to start here, cross that off, cross this off. I'll cross one of these 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 off. What's left is the 4 3/8 right in the middle. And I apologize if that's a little sloppy. It's a little bit difficult right now on my small screen. I think you guys can understand what I'm doing. All right, that was the work from yesterday, so we will move on and get into today's lesson. Our agenda for today is to continue to learn about line plots, learn about our workplace station 6C. I'll show that to you, and then continue to work with fractions and mean, median, mode, and range. Our learning goals are I can recognize equivalent fractions. I can use visual models to explain why a fraction is equivalent to one another. I can convert a mixed number to a fraction and vice versa. We've done that in the past as well. And I can add mixed numbers and fractions with like denominators. And we got this really weird looking, funky looking picture down here. But I guess it's kind of funny. All right, today's vocabulary. Some of these words should not be new, actually, as I look through them again. We have seen all of these before. So nothing is new, and you have been introduced to line plot now. So even though that is newer to us, mean, mode, and range, you have been hearing about that over the past few lessons. So we will continue to learn about that. This is our anchor chart right here. As always, you can freeze the video to look back at the anchor chart to help you out. I'm sorry we can't give that directly to you right now, but we'll continue to work on these so that they become much, much easier for you. All right, just as a little bit of reminder and practice, we have the cross-off method going here. You see, as they look for mean, they crossed off starting left to right, left to right, left to right, back and forth until all that was left were these two right here. So that's how they come up with a median of 1 1/2. A mode, because it's the data point that shows up the most, is also 1 1/2. And then the range is 2 1/2 because they take the maximum value. I'm sorry, the range is 2. They take the maximum value and subtract the minimum value. So in this case, it's 2 1/2 minus 1/2 gives you that 2 right here. All right, let's let's figure out how to play Workplace Station 6C. In this, you will need a record sheet, and there should be a record sheet for you in that packet that we sent home. Hopefully there is. I apologize if there's not. And you will need pattern blocks and a spinner overlay. And at this point, my class will say, but wait, Mr. Trice, we don't have pattern blocks. And I would say that is correct. You don't have pattern blocks. And there is no way for me to get you pattern blocks except for that you can find them on your computer. If I can get there right now, my computer's a little frozen. Here we go. If you look into your Bridges apps, and everybody should have that on their Chromebook, because I know that Mr. Hausman worked to drop that onto everybody's Chromebook. My class has opened those in the past. If you find that Bridges Math Apps section, and I think on your Chromebooks it might be towards the top left or bottom left side, go into the apps, go down and find pattern shapes. And when you click on pattern shapes, you will get something like this. So you'll see me click over to this at times when we are going through the Workplace Station game. This will allow you to use and play around with some of those pattern blocks yourself. All right, so let's play this game. Essentially what you are going to do is just click to the next screen. You are going to take 2 spins, and whoever ends up filling up their blocks first, there are 3 whole blocks here, wins the game. If you go over, you lose. What you want to do is use these different patterns here. Let me bring my pen back right now. All right, let's see if I can do this. Let's shrink that line. Let's see if that works. Okay. This equals 1 whole, and I'm going to write it as sixths. 6 sixths equals 1 whole. The trapezoid right here would equal 1/2. Oh, I'm sorry. Let me erase that. So we have 1/2, which of course equals 3/6. We're going to ignore the square and go down to the rhombus. The rhombus equals 1/3, which of course equals 2/6. And then finally, we will use the triangle, which in this case just flat out equals 1/6. And you'll see how that plays out as we go through this game. What I also will tell you to do is think about these in terms of a common denominator. So up here, 1/2 would equal 3/6. 1/3 would equal 2/6. 1/6 is 1/6, of course. 2/3 would equal 4/6. You have 2/6 and 5/6. That is going to make it much easier for you guys to add, for those of you that are able to already bypass using the shapes. So here we go. I'm going to spin. I get a 2/6, and then I need to spin again, and I get a 1/2. Now I'm going to jump over to my pattern blocks here. I have, let's see if I can draw with my pen. I have a 2. Oh, it's not going to stick. Let's see here. I have a 2/6 and a 1/2. I apologize. I can't write on here. We'll just have to remember those numbers. What I'm going to do is pull out the hexagon. The hexagon represents 1 whole. Now I have a 2/6 and a 1/2. The 1/2 is our trapezoid. And I'm going to actually turn it upside down so it looks like what you guys see on your Workplace Station game. And then the 2/6 would equal 1/3. 1/3 would actually be our rhombus here. If I add that 1/2 in that 1/3, I'm left with just one of these. And if we go back to what we said here, one of those equals 1/6. If I add these up, they equal 5/6. So we have used up 5/6. In other words, our 1/2 plus, what did we spend? 2/6 equals 5/6. Now, for those of you that like to turn that into a common denominator, I am going to do it like this. We have 1/2 and 2/6. We want to find a common denominator. So if I were to go down here and start writing the multiples for 2, I would get 2, 4, 6, 8, 12. If I wrote the multiples for 6, I would get 6, 12, 18. We'll stop right there. We want to look for the first common multiple. First common multiple is 6. So that means we are going to use a 6 and a 6. Well, what did we have to do to turn 2/6 into this? Nothing really, because we multiplied the 6 by 1 and the 2 by 1, we get 2/6. What did we have to do to turn the 1/2 into this? The 2 had to be multiplied by 3. So we have 3 times 2 equals 6. My class knows if we do something to the bottom, what do we do to the top? You guys can say it. It's the same doggone thing. So if we multiply 3 down there on the bottom, we are going to multiply 3 up there at the top. 3 times 1 is 3. And that's how we get a 3/6 plus a 2/6 equal a 5/6. Because 3 plus 2 equals 5. And obviously, as you guys already know, we don't add the fractions on the bottom. It stays the same. So that's how, using common denominators, we can get to the same answer. Now remember, as you spin those, you want to keep spinning until you can get as close to 3 holes as possible. I'm going to move these over so you can see what we would have done for our last spin without going over. If you go over, you lose. Whoever gets the closest to the 3 hole numbers, you're the winner. All right, so go ahead and have fun with that. Have fun with our pattern block shapes over here on your math app. I know that everyone has those on their Chromebooks, so go ahead and try that out and play with it and see how that helps you. All right, let's go back and move on to one of our math problems. So if you, our math book problems today in our yellow book will be page 242. Looking at the first problem, it says Melinda is playing fraction, spin, and add. She spins 1/6 and 2/3. What is the sum of Melinda's spins? I'm going to show you with the common denominator again. You guys are welcome to use those pattern blocks on the pattern block app to help you with this. And for some of you guys, it'll be a great feature for you to use. But if you want to do the mathematical method, then you can go ahead and follow along with what I'm doing right now. So we have 1/6 plus 2/3. We want to turn that 2/3 into 6. So again, I'm going to list my multiples to find the first common multiple. Multiples of 6 are 6, 12, 18. Multiples of 3 are 3, 6, 9, 12. We'll stop there. I can see that my first multiple is 6. So I'm going to use that. All right. How many times does 6 go into 6? Goes in there once. So we have 6 times 1. Well, at the top, we also take the 1 times the 1, and we end up with the same fraction. If we go to the other side, we have 3 going into 6. How many times does 3 go into 6? If you said 2, you would be correct. So 3 times 2 equals 6. If we do something to the denominator, what do we need to do to the numerator, guys? Your answer should be the same doggone thing. So at the top, I'm going to take 2 times 2. Do the same thing. 2 times 2 is 4. Now we have a common denominator. We can add straight across. So in short, 1/6 plus 2/3 equals 5/6. That would be your answer right here. The sum of her spins is 5/6. What pattern blocks did she put on a record sheet? So she used the fewest pieces. That's where you can go back and use this app if you want to figure that out. The pattern blocks that we would have in this case, let's see, 1/6 would be a green triangle, and the 2/3 would be a 1/3 rhombus and another 1/3 rhombus. All right. So I want you guys to work through the rest of these problems. I don't want to do all those problems for you because then what's the challenge for you? As always, if you have questions, please go ahead and contact your teacher. And then the rest of your homework will be these 2 pages in your pink book, which are pages 125 and 126. So total complete page 242 that we were just working on in your yellow book. And then in your pink book, I want you to complete pages 125 and 126. And those pages will have some more fraction type problems. Just remember when it asks you about dozens, there are 12 in a dozen. And then when it is asking you to multiply your fractions or divide your fractions, sometimes it's easier just to break apart those fractions. Definitely if it's a mixed number, remove the whole number, work with that, and then work with the fraction separately. So good luck with your work. If you have any questions at all, don't hesitate to contact us as teachers. We hope all is going well. We miss you guys. We love you guys very much. Take care of yourselves, get out and play, and enjoy your families. All right, take care, guys. Bye.